Okay. Let me share my screen. Yesterday somehow I could able to fix the memory issue. I have cleared some memory and I have freed up some about 50 GB.
Yeah,
So
Rahul,
I
if that
guess
Valgrind, then I will share my screen.
it will be fine. If I face any issue, I will
Yeah, okay. Yeah, fine.
yeah. Okay, because I am sharing it is easy for me to explain and then point out the code.
Yes, yes.
So yeah. So Mahesh and could you see my screen, right?
Yes, yes.
That's great. If you remember yesterday, Mahesh, can you brief me about what we discussed yesterday?
About unique pointer and how the
Yeah.
instance works, how instance will
Mm,
be controlled, and about the move semantics.
exactly. To give a refreshment, so then why we are going for smart pointers, by the way?
To avoid the what we say missing of releasing memory or freeing memory.
Exactly. So to avoid the manual deletion of memory, we are using smart pointers since there is sort of chance that developers may miss to delete it manually, right? So that's why we are
Yeah,
going for smart pointers, and we have three smart pointers: a unique, shared, and weak pointer, right? And yesterday we were talking about the unique pointer, and this is an example for a unique pointer. Since yesterday I couldn't be able to communicate that much, maybe today I will brief it one more time. See, Magesh, we have a class called test pointer, right?
yes, yes.
And in the public section I have a declared on variable for a sake of example int a, and then this is my constructor, the simple constructor default one, and I have a function called display that just let's say I'm just printing the value here, a, something like that. Let's do one thing. In constructor I will make a parameterized like int x, and then I will use initializer list to assign the x into a. Did you got this right?
Yes, yes.
So I am passing a, I'm while creating an object, right? I am passing a variable, I mean passing a parameter. That parameter I am storing into int a. Okay, then I am printing it into a display function here. Whatever I am passing, I am printing it. This is a simple one, and I have a destructor at below. It's a simple destructor. Okay, then at main function, right, what I will do, just a second guys. Yeah, I think Shankar joined.
Yeah, yeah.
Hey Shankar, actually just now we started. So since we are yesterday, I couldn't able to give a demo, right, using a memory thing. So today I have installed an Ubuntu. So I was explaining the yesterday's concept, just refreshing it. We have a test pointer class here. Okay,
Okay.
right now we are talking about the unique pointer. This is the example for that. Here there is the class name called test pointer, and in a public section I have declared one variable for a sake of example, int a, and then here I have a constructor. This have only one parameter. So while creating an object, right, whatever we pass it, we just okay.
Your
Rahul,
voice is breaking.
we lost your voice. Hello?
Right. So
Rahul, can you repeat? We lost your voice.
okay. How about now?
Now fine.
Okay, okay, okay. So we have a constructor, parameters constructor, and we have a display function here. There, whatever we are passing into constructor, we are just printing it here. That's it. It won't do much, and we have a destructor here. Okay. In the int main, okay, we will remove these things. So let's create an yesterday's example. There are two methods of creating a using sorry, two methods of creating a unique pointer, right? Method one is this one. I will uncomment it. Yeah. So this way pointer here, since unique pointer is a template class, right? instead of in the Angular braces, I am passing a class name here, followed by an object name. My object name is obj. Inside an object, I am passing a dynamic memory allocation. Okay, just like above one at line number 29. Okay, this is one way of creating it, but this way have a limitation that it cannot handle an exception. Okay, this is not an exception safe method, so this method is not recommended, by the way. That's why we have a method 2 that has a unique pointer syntax that will handle an exception in case when you are allocating a memory, right? If there is an exception, this will immediately throw you. Okay, so that's why we have using this syntax. This syntax for explanation, right? Since this is a unique pointer is a std namespace, then we have a std and we have a scope resolution. A unique pointer is a keyword, and since it's a template class, in parameter we are passing a class name and object name. Okay, and we are assigning initializing this object the make unique method. Okay, okay, then in the make unique method passing a test pointer here. Since the class is a parameterized constructor, right, here I should pass some value here. Let's say I'm passing 100. If it is a default constructor, then I don't need 100 here. Since I have int x there at line number 9, I have to pass 100 here. Okay, so once I pass 100, I am assigning it object 2. Okay, let me comment of this line. We go step by step. Yeah, first we are creating a unique pointer syntax. Let me compile it. Saving it. Okay, I am opening another terminal. G++, C++ compiler name, and memleak dot cpp. Compiling it. Then I am executing it. Okay, I am getting constructor called and destructor called. The difference is yesterday when we are using this new pointer, right, at line number 29, we have a new here. When we are creating with this, right, if we didn't put delete, then destructor is not calling, right, if you remember. So right now we are achieving the same functionality using a unique pointer. Here both constructor and destructor called simultaneously, I mean back to back, right, even though we didn't mention any delete here, right? So without mentioning a delete, so it could able to free up the memory. Okay, it starts with main. Once it comes out of main at line number 55, when it reach the program flow reach line number 55, okay, this C++ knows that okay, I'm going to out of scope, then I will be calling a destructor automatically. So this is the advantage of using a unique pointer, and the one property of unique pointer is it cannot be copyable. Okay, we cannot copy one unique pointer to another variable. Okay, it's a single instance for entire scope of a program. So it has advantage. If you yesterday, right, the scope of this unique pointer is like you can
Rahul, you're not audible. Mesh is only for me or for you also?
For me also it is happening.
use it
Yeah.
for logging system, right?
Yeah.
But
Rahul, can you repeat last?
yeah, from logging, right?
Yes.
Yeah, so yeah, the one advantage of using a unique pointer is to log the data using a logging system where you will create only one instance of a logging class, and then you will use that one instance again and again to store the logs. Okay, to avoid the multiple instances. Okay, this is one use case, but if you find some other use case, right, we can discuss it in upcoming classes of unique pointer. Yeah, so in short, I could say that this pointer we created without we have created a dynamic memory allocation here, but we didn't delete it manually, right? So it automatically handled the memory. But as per the property, the unique pointer cannot be copied into another object. So for example, let's say at line number 39, I am defining another pointer called obj3, right? And what I'm doing is, let me comment out the below code from here to here. What I'm going to do is obj3 equals to obj2. Okay, I'm trying to forcefully copying that obj2 into obj3. Okay, by the property it should not allow me to do that, but let's see what happens. And here I'm going to call the method here. Okay, let's first do this until this. Let me compile it. It should not allow me to compile as per its property. Yes, so yesterday we get the same message, right? In Windows, like right now I'm in Linux, so anyway the error message is same. It's use of deleted function unique pointer. In short, it means that it won't allow the multiple instance of unique pointer to exist in the code base. Okay. As first property, this is not allowed. Yeah, we are getting the expectation. The error is expected, so this is not allowed. Yeah, and one more thing, you can copy with only one method. Okay, so you can using there is an operator called move operator in C++. It's also belong to std namespace, but using this, right? So using this, you can change the ownership from. So right now this pointer, right, this is holding the ownership is held by object2, right? Now I am in this line, commented line, I am trying to move the ownership like this. I'm trying to copying like this, which is not allowed. But there's only one way of doing that. That is using a move operator. That how it moves is, it takes an parameter of object2. Okay, right now the ownership is object2. I am storing it under object3. Okay, and the object2 will move to null. Hello,
Yeah, Rahul, I understood.
you're there. Yeah,
Yeah.
you're there, right? Okay, yeah. So I'm just moving the ownership from object2 to object3. After moving that, what our compiler will do, right? Object2 makes to point to null pointer.
Yeah, understood.
Yeah, so now what I'm doing to test it, in theory we know that object2 will be null pointer after moving the ownership, but let's understand it practically. Once I move to object3, right, what I'm going to object2, I'm going to access the class. Let's
40
see
minutes.
how it happens. I think my voice got cut in the middle.
Yeah,
It
Rahul.
was it was clear till you're going to check again in the object two class. After that, it was missing.
Okay, so I was telling about the ownership, right? At line number 45, I am moving ownership of object2 to object3, right? Until that you understand, right?
Yes, yes. You said like after that you're
Yeah.
going to check the ownership of object two. Then it was
That's great. Yeah, thanks, Magesh. Yeah, thanks. Yeah. So object2, I am trying to call a display function here.
Rahul, again we lost your voice.
Yeah, actually I didn't speak. Now only I'm speaking.
Okay. Okay.
Yeah. So after moving the ownership, right, I am trying to call the display function using object2. Okay. By theoretically, we know that object2 points to null. Okay. But now let's see practically. So I am building it and I'm trying to running it. Yeah. See, you can see a seg fault here, right? Even though the constructor get called, but anyway, when it reaches to here at line number 47, right, we are trying to call a memory that is already freed, that is already moved. So object2 doesn't hold the ownership anymore, right? So this seg fault is expected one, and that's why in C++, right, you should be always check object to null. If it is null, don't call it. Okay, let's do in this way. So doing like this is not a good way. And if you see it, this is another proof that the object2 is pointing to null. Here at line number 50, right, I have an if condition. I'm checking whether object2 is equal to null or not. If it is null, then I will be calling a cout here, null pointer, something like that.
Your voice is not audible, Ram.
He's on mute. Rahul, you are in mute. Hello? Maybe because of virtual machine. No, Rahul, still not audible.
How about now?
Now fine.
Yeah, bro. Okay, guys, let me do one thing. Just give me a second.
Okay, Rahul.
I don't know how much I cleared the memory. Still, I am getting that. Just a second, guys. Guys, am I audible now?
Yes, Rahul.
Okay, that's great. Could you see my screen?
Yes.
Okay. I have closed that VMware. So we
Okay.
quickly have a code here. It's the same code actually we have where we left. We left at null pointer, right? So at line number 39, after I'm moving the ownership from object 2 to object 3, right? I was on previously I was trying to call the display function. Oh, sorry. And I was trying to call it. Okay, but here we couldn't see that exception. Okay, anyway, if you see that in Ubuntu, right, we could see some exceptions like segfault, right? So one proof is like we have
Yeah,
if condition here.
Rahul, in GDP we didn't get segmentation fault. Even if segmentation fault is there also, it won't identify the segmentation fault.
Yeah. In GDP, it
Mm.
is not showing up.
Yeah.
Yeah, correct. But in Ubuntu, did you guys see it?
Yes. In
Oh, okay,
Ubuntu it
okay,
is
okay.
shows segmentation
Yeah, yeah,
fault.
yeah, yeah. So one thing we do, we know that the object 2 is pointing to null. So what we do is we forcefully check it to null. So if it is really pointing to null, we will be getting the C out here. Okay. If I try to run it, you could see this, right? I am null. So that means that since in GDB it's online compiler, we couldn't see the sec fault, but in reality, this object2 is pointing to null, and this is the proof. Okay, and if you are not, let me comment out this line, right? If you try to run it, then you won't be getting that null because the ownership is not moved yet. Still the ownership is with object2 only, so it's not null. Once I move to ownership to object3, then this becomes null pointer here. You could see it below, right? So the points we learned here is, so point number 1 is unique pointer, single ownership. Okay, even if you want to move the ownership, you can use move operator, use std move to reassign ownership. Okay, and what else? Yeah, so no, yeah, for now you can remember these 2 points. So the unique pointer holds single ownership. It won't allow multiple copies of the pointer, but still if you want to copy it, you cannot copy it, but you can move it. Okay, you can reassign the ownership to some other object. Okay, guys, until now you understood?
Yes, sir.
Okay, great. So shall we move to a shared pointer? Maybe we can understand a little more the difference between that.
Yes.
Yeah, fine.
Okay. I think in VS Code also the segmentation fault won't show, right? Let me check it once. I have a same code.
Yeah, yeah, it is not showing. Yesterday we tried.
Okay.
Yesterday we tried in both GDB and this uh, VS Code also.
Oh, fine, fine. All right. Okay. Okay. Let's do one thing. So now we will see the shared pointer topic. So I have a same class here. Class test. Okay. I will use the same class itself, right? We will take the same example. Okay. But instead of unique pointer, we are going to use a shared pointer. Okay, int main, same thing I have. The syntax for shared pointer is the same way. It belongs to a std namespace. So std shared pointer. So like unique pointer, this is one way of creating a shared pointer. We will see the 2 methods. This is method 1 of creating a shared pointer. Okay, so in parameter I am passing a dynamic memory allocation manually. Okay, this is one way. The advantage of shared pointer, right, it allows multiple sharing of objects. Okay, so unlike unique pointer, it allows a multiple copy of a same object. Okay, so for example, let's say shared pointer 1 I am creating, right? I will be creating another shared pointer. The working is everything is same except the fact that the unique pointer won't allow the copies, but this makes this will allow a copy of shared pointer. It will make the 4 pointer pointing to a same location. That is possible using shared pointer. Okay, so one example I can say is, let's say ptr1 equals to ptr2, and I have created a shared pointer above, right? I am assigning the above to ptr1. Okay, this is technically possible using shared pointer. Let me try to build it using the same command g++, and if I run it, it executes. Okay, it's also a part of dynamic, part of smart pointer, right? So the destructor will be automatically called without a manual way of deleting it. But one advantage of shared pointer is it it has a function called use count. Okay, that keep tracks how many copies you have made. Okay, I will show you that function that belongs to a std namespace still. I can print C out. Yeah, it's suggesting that me. Yeah. So if I put ptr1.useCount, right, the useCount is a method function that is defined inside SharePointer class. Okay, we know that SharePoint is a template class like a unique pointer. Okay, inside the SharePointer class, we have a member called useCount. Okay, we can use this useCount. It will tell us how many copies of pointer you have made it. Okay, let me compile it. And if I run it, it tells use count is 2, right? How means one copy we already made here. This is the first copy we are making. When we assign to ptr2, right, it makes second copy. So it keeps track of the object, how many copies you have made it. Okay, and when the destructor will be get called, if both the object goes out of scope, then destructor will call automatically. Okay, if you, the one point to note down here, the destructor will not be called twice. Okay, because the memory is same, we are just making a copies of the same memory. Okay, once the use count, the both copies went out of the scope, that is once the program flow reaches line number 42. Okay, okay, it understands that okay, now we are going to exit the main function, now we are going to out of scope, then before reaching that, it will call this destructor. This is the advantage of using a shared pointer here. And as unique pointer, right, this method is not a recommended one because of an exception safe. This is not an exception safety. Let me comment out this code. Let me comment out this too. So the syntax is almost same. Std make shared. Okay, if you remember, at the unique pointer we have been using std unique, sorry, yeah, make unique, right? Here we are using make shared. Okay, that's all the differences, and all the rest of the methods are almost a same one here. Okay, so instead of pausing a new test pointer, right, dynamically, this is the same function thing which it do automatically. It dynamically allocates the class, the test pointer, and assign it to ptr1. Okay, right now if you use ptr1 that use count, right, it should print 1 because we didn't make any copies yet, right? If I try to run it, then the use count is 1 here. Okay, actually, if I tell it more detailed, right, let me open a paint. So shared pointer, this is the important interview question. You could say the shared pointer, let's say it divided into two blocks actually. Okay, one is called a managed object, MA, manage object. The other block is called control block. Okay, so the shared pointer have two blocks of memory. This is the part which it is making a new, right, it is allocating a memory or using a dynamic memory, right, new test pointer or make share. This comes under this block, managed object block. That is that paint. So this comes out here, the new, using a new operator. Okay, the part that uses reference use count, right, it knows how many use count it's going on, right, that comes under, that is controlled by control block use count. Okay, one thing is, this is a new thing I got recently, like the control block is a thread safe block actually, because when you are creating a thread, right, multiple threads, this control block will keep incrementing the objects count. Okay, let's say 5 threads are creating manually, and 5 shared pointer will be created at the same time, right? So in that, the reference count will be 5, the use count will be 5. So this is a thread safe method. But the manage object, right, which we are going to create with the using new, this is not a thread safe. For this block you have to manage it very carefully when you are creating a thread. maybe at upcoming class, right, we will have one session with threading, and we see how it works in a threaded way. Okay, so right now you remember, like the shared pointers have two blocks. One is manage object block that takes care of a new memory, I mean dynamically allocated memory will be taken care by this block, and the use count and the other function will be taken care by a control block. And this control block is a thread safe block, and the manage object is not a thread safe, but the user should, or the developer should, manage it with carefully. That's what this does. Do you guys understand? uh,
Yes, sir.
okay,
Yes, sir.
that's great. Right now I'm going to tell one very important thing here. Actually I should have told before this learning a shared pointer, but I think it's not too late. Okay, so let's do one thing. uh, Let me create one example here. Let's say I have a basic class syntax, right? I have a test pointer. I have a default constructor with no parameters, just a basic one. I have a display method, it just prints display function call. That's it, and have a destructor. Okay, what I will do is in a main function, right? I have return here. So here I'm going to create an object for this class. Let me create an pointer to a class ptr, and ptr I'm using an array operator because it's an pointer, not a normal one. Okay, that's it. So what is the output you are expecting here? Tell me in sequence which one get printed first and which one will be printed last.
First, the constructor will be called.
All right,
Then the display has to be called.
display this function.
Yeah, display function.
All right,
Freed the memory, destructor won't be called.
that's a good observation. Yeah, so as you told, I'm compiling it. When I execute it, yes, constructor call and display function call, but the memory is not freed yet. So if you use a Valgrind, right, you will say some memory violation is not freed. Okay, but this is okay. But what if I say, so what do you think will happen now? Any idea?
Here, object is assigned to null.
Yeah,
Since there is no memory allocated, it won't enter, I guess.
okay. Anvesh, do you have a installed Ubuntu on the this G++ compiler?
Yes, yes.
Okay, Anvesh, can you run this code in your system? Let me share you that, because it's a very important topic which you need to understand. Chat box is here. Yeah. Anvesh, I have shared you. Anvesh, actually, your voice is not audible. Maybe some mic issue.
Now?
Yeah, yeah. Now it's good.
Yeah. Okay, given I will try.
Yes. Yeah. So here, yeah.
Can I open
Uh,
that?
yeah, you open that code once.
Yeah.
Yeah.
Wait, I will
Uh,
set the number.
yeah.
Yeah. Is it fine, Rahul?
Yes, Magesh. Yes, Anvesh.
Yeah.
So, Magesh and Shankar, what do you think? This will. Do you think this will work, or this will throw a segmentation fault, or it will print something?
I think it will throw a segmentation part.
Yeah, like since there is no memory allocated, there won't be any functionality.
All right. Okay. Anvesh, can you build the code?
You can use Control R command, Anvesh, since it will move to. It will show all the.
Yeah.
You
Yeah. Yeah.
can you can use Control R and then type G++.
Okay, okay. Now
Yeah.
again
Now,
try.
now run the binary. Yeah. Dot slash a. Yeah. If you run, we couldn't see a seg fault here, right? Even though the pointer it's null, it could still call the display function, right? Now let's do one small change. Unpage at public section, right? Declare one variable of integer a.
Line number.
Go to line number 9. Yeah, click enter. Declare one variable of type integer, int a or int x something.
No, no, inside the public class. It's like,
Yeah,
Here.
yeah, int var. Yeah. Now initialize this variable inside a constructor at line number 13, or you can just hard code it, no problem. Like var equal to 30 or 100, like that. Yeah. Now at line number 19, right? After include that variable here, print that variable along with the display function called. In the same line, try to print it. Yeah. Put arrow that left. Yeah. Type where. That's it.
That's it.
Yeah. 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 Now save the code and compile it. Yeah. Now run the binary. Do you see here the difference? So the previous code without a variable, we have only a function. We don't get any seg fault. It could call the function even though the pointer is null pointer. But now we have introduced a small variable, okay, and we have used inside a display function. If I try to run it, it gets seg fault here, right?
Yes.
yeah, I got
Yeah, this is a very important topic which you have to understand.
because
Maybe yeah,
yeah. Before the display function not have any variables. That's why it's printed.
exactly. That's true.
Now we have declared one variable.
Hmm.
Now it's throwing a segmentation part.
Exactly. So,
Right.
but still the pointer is null, even though we don't have a variable, right? But still it could able to call it. But we thought it will throw an error. It should not call the function as per theoretically, right? Since the pointer is pointing to null, so we just dereferencing the null address. We should get a seg fault. But in this case, we are not getting any seg fault if we don't have a variable. But as Shankar told, after we introducing a variable, it gives a seg fault. There is something going on with the variables and the instance. So before I tell the answer right, I need help of you guys to tell me what's happening. Maybe by next class.
By next class, what? Once tell me about.
Yeah, yeah. In next class, right? You guys can tell me why when using a variable it gives a seg fault, but without variable we are not getting a seg fault.
I think because since there is previously when displaying the just display function, there is no memory associated.
Okay.
But when we are having a variable and which needs a data storage, so it is causing, so to print just a display C out, there is no memory involved, right? So
No, but it still need a memory to store a class. We have a memory created at line number 31, right? We have a local variable here. In that,
yeah, yeah, without that
Yeah,
local variable, there is no memory, right?
yeah,
yeah.
Rahul. Okay.
So if there
Yeah,
is no variable associated, I think like since there is no memory needed, even with null also it can display the data. Simply it's just a C outline, right? So no memory is needed to store that line and like anything like that.
yeah, Rahul. My understanding is the pointer is pointing to a null.
Mm-hmm.
We are now we are pointing to a number. It will not print like it will print like segmentation part like that.
Yeah, yeah. Both are right partially. Yeah.
Because
That.
pointer is pointing to null is like a nothing.
Mm-hmm. Yes.
That's
It.
why it's not.
Okay. Yeah. It's nothing. But if the function don't have any variables used up,
Yes.
then yeah. So it's partially correct. Maybe in next class, right? Maybe I will
Sure,
tell you
sure.
one more example.
Yeah,
Yeah, yeah, yeah. That's
We'll
right.
also try and research, like do some research how
Yes,
it's
yes.
like
Yeah. So
we
to
have
give,
some understanding, but I'll confirm it like in the next class.
yeah, yeah, yeah. So the hint is like there is something. Okay, I didn't explain you about this pointer, right?
Yeah, this pointer you didn't explain, but I have an idea.
Ah,
Like,
all right. Okay, okay. Maybe next class we'll see about this pointer. Why we need that? That gives answer for this question actually.
okay,
okay.
Yeah, yeah, yeah. Okay, guys. So today we end here.